We'd like to begin our presentation by saying thank you so much for reviewing the work that was accomplished as part of the CS410 Text Information Systems course offered through the University of Illinois. This is the final project for Megan Massans and Cynthia Johnson. Our objective was to provide a patent search web application for researchers within one of our organizations. Due to the innovative work these researchers are performing, even their searches need to be protected. As such, the use of Google or Google patents is entirely disabled. Specialists with limited licenses use specialized software to provide these searches to the researchers. Our goal was to provide an application directly to the researchers. During our presentation, we'd like to provide an application overview, discuss how to install the software, how to use the software, and follow it up with a use case example of how to test the software. We'd like to begin with an architecture overview of the application. CSV files are made available through the patentview.org website. This information was loaded into a SQL Server database. Once loaded into the SQL Server database, a view was created in order to join the data sets together. This data was fed into Azure Search, which provided the TF IDF weighting of the data. In addition to the patent data, we have a SQLite database for storing user and past search information. As this application moves into production, we'll actually be using Azure AD integration. In order for TAs and instructors to be able to view this application, we needed to not use Azure AD integration, as you would be entirely blocked out of using the application. As such, we decided to use a SQLite database to temporarily hold this information. Within the Python environment, we use WT forms as well as Jinja2 templates to enable rapid development of our web app. We used SQL Alchemy as our ORM for the SQLite database. We used NLTK to perform bag of words on the patent titles, and D3 in order to provide a word cloud of the patent titles. We also used GenSim to provide topic modeling on the patent abstracts. All of this is wrapped into a Python Flask web application that's deployed out in Azure. We'd like to show you the patentview.org website and the data sets that are found here. If I scroll down to the patent CSV file, you can see there are over 6 million records. This information was joined with summary information, location information, and company information to provide basic information that would enable researchers to get a good understanding of what patents are currently available and who their key competitors are. We'd like to go ahead and show you the application before we go into detailed instructions on how to use the application. We come here to the welcome screen where we can see recently searched information. This allows for sharing searches across users. I'm going to go ahead and sign in with an already created user, and we'll go ahead and go through this in more detail later in the presentation. I'll go ahead and log in, and I can see my previous searches, as well as perform new searches. Putting in information into this text box allows for searching across all of the fields that are performed or provided within the view, the SQL Server database view. That is then fed into Azure Search for scoring. I can go ahead and look for something like an electron microscope and say I'd like to search for electron microscope data and filter it by information found within the US. I'm going to go ahead and sort by the score and return 10 patents. Performing this search, I can see the title word cloud and the keywords found within the titles of the patents. Following this information, our LDA topic models and HTTP topic models from the abstracts. This provides researchers with a really quick view of the information that's found within these patents. This will allow them to quickly see if the search that they've provided is going to return relevant information to the search that they performed. In addition to this, we have the top-ranked companies and the number of patents they have in the search results for our patent search. This provides quick insight into key competitors within a specific arena. After that, the patents themselves are returned. The patent title is at the top, followed by a table, which provides the score of the results, the patent number, the number of claims, the patent date, the organization name, the kind of patent, the country, state, and city. And this is followed by the abstract of the patent itself. Providing this information to researchers allows them to see quickly what information is publicly available on patents that have been created. Note that based on the patentview.org website, we see that these searches will return information as recent as August 8th of 2017. Next, we'd like to discuss how to install the software. Fortunately, no install is actually required in order to run this application. The application is housed in Azure. The code is found within a repository out on GitHub. However, detailed instructions are available in order to run this application locally. We did have many trials and tribulations in order to deploy this application within the Azure environment. We found a great blog post that allowed us to do this deployment. We wanted to ensure that regardless of where the application was deployed, that our deployment process would be the same. We went ahead and used wheels in order to enable the install of the requirements. So our first step is to clone the repository, following in the install of wheel, and then to do an install upgrade of the requirements. After the requirements have been downloaded, we have a setup.py file that will download the NLTK stop words and pun KT files. These are required by the application. In addition, we also have a runserver.py file. This could be used to drop or create the SQLite database holding the user information. So going out to GitHub, we'll see in the README are the steps required in order to clone the repository, install the requirements, and get the application running locally. We've gone ahead and cloned the repository. Reviewing the information out on GitHub, we can go ahead and do a pip install of wheel. Following that, we can go ahead and do an upgrade of our requirements. As discussed within the README file, the location of the requirements file will be in your local repository, so we will need to modify the example provided below. That I've gone ahead and done right here. I'm going to go ahead and run this, and we can see that Wheelhouse is actually being ignored. This is not ignored within the Azure environment. As you can see, the install occurs successfully as we've done in a previous instance. All the required libraries have been installed and are now available for the application to use. Coming into our application, we can go to the setup.py file and run that in order to download the stop words and the punkt file. Once the download is complete, we're able to run the application locally. We can go to the app.py file and go ahead and hit run. The application is now running locally. Because the application uses the Azure API, the same information is available regardless of if you're running the application locally or you're running the application within Azure. However, the web app is able to run locally on your computer and use your local SQLite database to hold the user information as well as past search information. Now that we've discussed how to run the application locally, we'd like to discuss how to use the software. The first step is to create a user. This is accomplished through the sign up link. Signing up for the application, we need to provide a username, email, and password, as well as password confirmation, and click on the Create button. We use WT Forms validators as we create our users, which means that there's some basic checks that are done, including ensuring that a user doesn't already exist and that we have a valid email address. Here I'm at the welcome screen within the application. I can go ahead and say, sign up. As you can see, we're greeted by Z001 is a popular name. Apologies, it's already been taken, as well as the email address already exists. I can go ahead and create a user that doesn't exist. And then I can go ahead and log in. I will see that my user has not yet performed any searches, which is true because this is a new user. Here again, we're showing the creation of a user and then following the login. As discussed, this user has not performed any searches, so we won't see any search results. For testing purposes, if you would like to bypass creating a user, feel free to use the user Z001 with the password of 123MEG. Now we can begin searching the patent data. The text box searches across all fields that are within the SQL Server view. We're searching across over 6 million patent records. We can use the search filtering criteria to pan down the results. We can filter based on country, a patent number, company, kind. We can sort by either the score or the date. If we'd like to search by date, that might be because we want to see the most recent patents established within a particular field. We're also able to use skip. Skip and take are sort of common terms when dealing with APIs. A reason that someone might want to use skip is perhaps you've done a search and you've looked at the top, say, 20 results, but now you're curious what the next 20 are. If you put in a skip of 20, it will begin with record 21. So we are not limiting a user to what patent data they're able to see. All of this data is available on the patentsview.org website. So we can go ahead and search, and note that I was asked to log in because I didn't say keep me logged in. I'm logged in as Z004. I'll go ahead and search. I can say I'd like to return 20 results. And again, I see the title word cloud, the models that were created, and the companies as well as the patent numbers related to the search that I created, followed by my search results. The search score is computed based on statistical properties of the data in the query. As your search finds documents that include search terms in a query string, some or all depending on the search mode. If we put our search criteria within quotes, we'll be looking for an exact match. Favoring documents that contain many instances of a search term. The search score goes up even higher if a term is rare across the data corpus, but common within the document. The basis for this approach to computing relevance is known as TF-IDF weighting, or term frequency inverse document frequency. This is really the basis of the work that we've been doing within the CS410 Text Information Systems course. We wanted to use Azure Search because we wanted to ensure that this application would be something that would be supportable and deployable within a large corporation. So using the cloud and the resources available within Azure, we're able to provide this application, which can further be used and extended to work with existing applications within our organization, which is found to be a pretty exciting feature. Here we show searching for a sewing machine and clicking search. We'll go ahead and do that. This time around, I'll go ahead and say, keep me logged in. Here I've returned my search for a sewing machine. We note that the top 10 results are returned for analysis. By default, the top 10 is from the score, but can be altered by date of the patent creation. Note that we can, by using the return count, up to 30 results can be viewed at a time. A word cloud with stop words removed is created from the patent titles of the results. LDA and HTTP topic models are created based on the abstracts. The patent title is provided, and a table with key patent data information is also provided along with the abstract for further analysis. Let's go ahead again and search for sewing machine, and we'll use a country of US as our filtering criteria. Now we can note that the patent data that's returned is relevant to the country of the US, which means that the top ranked related companies and their number of patents is different than when we did a search without filtering based on the country of US. Going back over to the application, we can go ahead and scroll down in our results, and we see that the countries are in fact returned as US. In addition, the companies we'll see are found within the US. Now we'll go ahead and do a search, and we'll sort by the date. Before we do that, we can note that the top search here is showing a result from 1995. Now when we look at our results, we can see that the patent data, while the score is returned, is much lower. The patent date is as recent as August 8th of 2017. Now we can go ahead and look for search using sewing machine in quotes with the country of US and a sort date and sorting by date. Here we will see that the score is much higher, but the patent is not as recent as what the information that was returned when we weren't using quotes around sewing machine. So note, sewing machine is required in the search, not just the word sewing or machine. Now we can review our past searches. For our newly created user, we can see our past searches. Now we'd like to go through a use case example on how to test the software. We'd like to search on transition electron microscopy. We'll sort by date and hit the submit button. The information that's provided will allow users to quickly gather insights to take action. The word cloud quickly provides insight into the patterns that are established. The topic models reveal keywords to explore for additional research. The top ranking related companies and patent numbers provide key competitors revealed in a quick and easy format. Along with the top patent abstracts are available for detailed analysis. We would like to make acknowledgments for some of the resources that have been used within our project. The patentsview.org website provided the key data sets required to enable this search. Thanks to open source technology, we were able to provide the word cloud with relative ease. The initial code for creating the word cloud is provided at the link provided here. We did do some modifications so that the words would have visible text. So if a word is only used once, it's not tiny compared to the others. So you're still able to get a good sense of the importance of the words, but everything is sort of legible to a researcher. There's a great Pluralsight video on Flask, Python Flask web applications that we took advantage of in order to enable the framework for our application. We also used HTML5 boiler templates from Initializer to get us started with our web app. The blog post that we mentioned during the presentation is provided here. I think it's really key for anyone that wants to deploy a Python web application with complex libraries in Azure to take a peek at this blog post because it was really useful. We also just wanted to note that, again, we use Azure Search APIs in our application. You don't actually have to have a web app to use these features. This can be used, within any application. And so you can do something as simple as use Postman to make these API calls. So here, we've just got Postman installed, and we can quickly make an API call, get back the data, and sort of explore and filter. This concludes our overview of our application. Again, NLTK for the Bag of Words implementation, D3 extensions, GenSim for doing the LDA and HTTP topic models, Initializer for the boiler templates, WT forms, and WT forms validators were used. So this was a great opportunity to sort of understand and implement an application that can be used very quickly within our organization. And actually, not only are the researchers really excited, but actually lawyers who look at patent data are also very interested in this application. So I think that the opportunities that this thing will provide to our organization are sort of limitless at this point. So we'd like to thank you so much for reviewing this application with us, and we appreciate your time and all of the efforts that you guys have also put into this course for us. Thank you so much, and have a good vacation holiday.